Welcome. We're going to talk about solving compound inequalities. We've been solving inequalities, so that's just like an equation, except for we have a inequality less than, greater than, less than or equal to, or greater than or equal to symbol instead of an equal sign. And it's just like solving that equation, except for we just have to remember that if we multiply or divide in our undoing process by a negative number, we need to flip the direction of the inequality. Well, now we're going to see these compound inequalities. And to start off in our notes today, this is 6.3. I'm just going to show you where this happens. So today we're going to talk about ands. We call it an and. It makes, on a graph, it's going to make a sandwich. But here's an example. Think about, for yourself, maybe you don't pay attention to the thermometer or the thermostat at your house, but what temperatures indoors, what temperatures inside are you comfortable with? Maybe talk to some people around you and see what they're comfortable with. Maybe you're not totally familiar. Personally, if it's below 65, I'm not happy. So I want the temperature to be at least 65 degrees. And I'm going to write this a little bit differently. I also want my temperature to be less than 70, or I can handle 75 degrees. That's about my limit. So I want my temperature to be less than or equal to 75 degrees, but I also want my temperature, I'm calling X my temperature here, I want it to be greater than or equal to 65 degrees. This is one way to write a compound inequality. My temperature has to be less than this amount, this bigger number, and greater than, or an equal to in these cases, that number. And so if we were to put a number line here, this is essentially kind of like a thermometer tipped sideways. I better see that mercury ending somewhere in between or on these 2 points. Now recall, if I lost the equality symbol there, that would become an open dot, or if that equality symbol was missing, that would be an open dot, meaning 75 is not a comfortable temperature for me, but anything below it would work up until 65 degrees. So that's just it. We have two limits now. So we're going to have 2 points on the number line and then some shading with respect to those 2 points, whatever makes sense within the inequality. All right, so that's an example, looking at temperatures. Maybe there's a salary range if you're getting your first job, or any job. Maybe there's a hourly wage that you're comfortable with, somewhere between $7 an hour and $10 an hour. You'll take that. Of course, you take more, but there's probably not that many options of an hourly wage out there that's much higher. There are some, but for a first job, not many. So there's that range that you think you would like and you could get. So now here's some generic examples of compound inequalities, and this kind of scares some folks. Remember back in the day when we were solving equations, we would put a line down the equal sign, and then we could have been putting a line down the inequality symbols. If you ignore this part right over here, pretend that was never there. We have two sides of this inequality. We have the -2 on the left side and the 3x minus 8 on the right side. And what we do to one side, we have to do to the other. We're trying to get x by itself. What's different now is now we actually have a second inequality. So now we have a left, a middle, and the right. And so that first question that we ask ourselves, what side is x on? Well, now we could actually say it's in the middle. So we're going to start solving this thing like we would normally, but this is kind of cool because now we're going to, what we do to one side, we do to the other. Well, now there's like 3 parts. There's kind of like 3 sides. So what's being done to x here? It's being multiplied by 3 and subtracted by 8. We have to undo subtraction first, so we add 8. What we do to one side, we do to the other. Whoa, we got to do it on the left and on the right. Woohoo, this is fun. So then we have to simplify 3 sides. We get 6. We get 18, and then we did that here to cancel out the -8, so we have 3x in the middle. And just like we've always been doing, we will drop down our symbols. So the less than or equal to symbols drop down. Last, what's being done to x? It's being multiplied by 3, so we're going to divide by a +3. And because it's a +3, we do not flip the direction of the symbol, so we get 2 is less than or equal to x is less than or equal to 6. Boom! So if we're talking temperatures here, maybe this is Celsius, but that's even really cold. I want my answer to be greater than or equal to 2, but less than or equal to 6. So now these would be closed dots because of the equivalent symbols underneath the inequalities. So there's 2, there's 6, anywhere in between them and including those numbers. You know, just for fun, I'm going to tweak example 5 here, and I'm just going to make that, let me try that again, just a less than symbol. So this one's less than or equal to, and this one's just less than. Alrighty, here we go. So if you'd like, x is in the middle. There's 3 sides now to this inequality problem that we're solving. So look for your variable that you're trying to isolate. X is in the middle. What's being done to it? Here's that subtraction sign. Let's add the opposite. To the x, we're multiplying by -2. Remember that minus sign essentially makes that a negative in this case. Add the opposite. So x is being multiplied by -2. And to the x, we are adding a -6. So we undo adding and subtracting first. So we're going to undo adding the -6 by adding a +6. What we do to one side, we do all 3 sides or parts. So we get 3. This becomes 0, so we just have -2x. This becomes 12. Bring down our symbols. We have less than or equal to here, and less than here. Check this out. This is x is being multiplied by a -2, so we need to divide by a -2. Ooh, we're dividing by a negative, solving an inequality. So we get -3/2 on the left. In the middle, we're just left with x. And on the right, we're left with -6. But we multiplied, or in this case, we divided by a negative. So we need to flip the directions of the symbol. So this less than or equal to symbol, opening up to the right, now becomes greater than or equal to and opens up to the left. This less than symbol, which is opening up to the right, now opens up to the left. So now this one's kind of funky. I think typically the ones that I've given you to practice aren't going to show up this weird, but realize that we're making a number line here. So this -6 is less than -3/2. So this -6 actually needs to go over here on our number line. -3/2 goes there, and then our 0, which we don't necessarily have to put on here, is over there. So make sure your number line goes from the smallest number on the left to the greatest number on the right. So then, reading this, read from the x. X is greater than -6. So big open dot. Make sure I see some white space in there. Open dot. X has to be greater than -6. That's to the right. This portion says that x is less than or equal to -3/2. So less than or equal to, that's a closed dot at -3/2, and then less than is to the left. Boom.